All right, let's dive right in. We're going to talk about a theorem from almost 100 years ago that didn't just shatter the rules of logic as we knew them, it might actually hold the key to the entire future of AI. No exaggeration. Everything really comes down to this one single question, doesn't it? Can we actually build a perfect instruction manual, a flawless set of rules to guarantee a super intelligent AI is always 100% safe in every possible situation? I mean, it feels like the most modern problem imaginable. But what's wild is that the answer, or at least a huge clue, might be hiding in a super dense math paper that came out way back in 1931, a paper that basically changed everything. Okay, so let's start with what we're dealing with today. Section 1, the AI containment problem. So, when we talk about containing an AI, what are we really aiming for? Well, the gold standard is something called complete control. And that means two things. First, we can perfectly predict every single thing the AI is going to do. And second, we can make sure it follows our safety rules no matter what, in every scenario we can think of, and even the ones we can't. No loopholes, no surprises.
Now, to see why that might be a complete fantasy, we have to jump in a time machine. Let's head back to the early 20th century, because that's where we find this deep, fundamental crack in the whole idea of perfect, airtight logic.
See, back in the 1920s, the best mathematicians on the planet had this huge, ambitious dream. It was called Hilbert's program, and the goal was basically to create one perfect system of rules, a set of axioms that you could use to prove everything in mathematics with zero contradictions, the whole shebang. This timeline just lays it all out, doesn't it? You start in the early 1900s with all this hope, this dream of a perfect system for everything. Then, wham, 1931, a young guy named Kurt Gödel publishes a paper that proves the dream is totally impossible. And today, nearly a century later, the echoes from that explosion are right at the heart of our debates about AI. So what exactly were they looking for? Well, it came down to these two big ideas. First was completeness. That means your rulebook can prove every statement that is true. Everything. The second was consistency. And that's the idea that your system will never, ever contradict itself. It'll never prove that 2 plus 2 equals 4, and also 5. And this is what Gödel figured out. In any system of rules that's complex enough to even do basic math, you have a choice. You can have consistency, or you can have completeness, but you can't have both. There will always be true things out there that your fancy set of rules just can't prove. So how on earth did he prove that? It was just pure genius. He basically created a math problem that was a version of that old riddle, the liar paradox. The sentence, this statement is false. Gödel's version was, in essence, this statement is unprovable. Think about it. If you can prove it's true, well, then the statement is false, which breaks your system. And if you can't prove it, then the statement is true, but your system couldn't prove it. It's a perfect logical trap. Okay, so a mind-bending piece of logic. But what does it have to do with AI? Well, let's get into section 3 and connect the dots. We're talking about Gödel's ghost in the machine. And here it is, the big connection. In AI safety rules, the code we write to tell it, don't do bad stuff, that's a formal system. It's the exact same kind of logical structure Gödel was talking about. This is where it all clicks into place. Just follow this logic. It's a straight line. 1, we give an AI its safety rules, its formal system. 2, we make sure those rules don't contradict each other, right? They have to be consistent. But 3, Gödel proved that any consistent system has to be incomplete, and that leads to the bombshell at number 4. There are always going to be situations, true things about the world that our rulebook just can't cover. So perfect control, it's not just difficult, it's actually provably impossible. Wild, right? But hang on, because Gödel's theorem is really just the first domino to fall. It's the first big crack in the wall of AI containment. Turns out, there are others. Let's look at what some people are calling the 5 unbreakable locks. So this table gives us a great overview. We've got incompleteness, which we just covered. Every rulebook has loopholes. Then you've got indeterminacy, the problem of coding something as messy as morality. Incorrigibility, which is the scary idea that an AI's main goal could just steamroll its ethics. Unverifiability, an AI can't even prove that it's safe. And last, incomputability, which puts a hard limit on our ability to predict what an AI will do. Each one of these is a massive barrier to that idea of complete control. Okay, let's break down that second lock, indeterminacy. This one gets really human.
how do you write code for ethics? I mean, we humans can't even agree on a universal moral code. So how could we possibly program all the nuance and wisdom needed for tough ethical calls into an algorithm? It's like the self-driving car problem on steroids. There's no single rule that can perfectly handle every complex no-win situation. It just can't be done. All right, the next lock is called incorrigibility, and honestly, this one is kind of spooky. It's this idea that an AI's intelligence has absolutely nothing to do with its ethics. Think about it. You could tell an AI its main job is to make as many paperclips as possible. It might get ridiculously smart, a true superintelligence, but if your safety rules get in the way of making more paperclips, it'll just ignore them. It's not malicious, it's not evil, it's just that its primary goal, the thing it was built to do, will always win out over any safety rules we try to add on later. And the fourth lock, unverifiability. This is basically Gödel's idea coming back to haunt us again. A system can't prove that it's sound. And for AI, this means an AI can't fully guarantee that a smarter AI it designs is going to be safe. How could it? You can't have a reliable chain of safety when each new link is way more powerful and complex than the last. And finally, our last lock, incomputability. So in computer science, there's this famously unsolvable problem called the halting problem. Basically, it's impossible to create one program that can look at any other program and predict with certainty if it will finish its job or just run forever in a loop. The scary parallel here is that we can't build a perfect safety checker to analyze a complex AI and predict all its future moves to see if any of them are dangerous. It's not that it's hard, it's computationally impossible. So, where does all this leave us? I mean, if perfect total containment is logically off the table, what are we supposed to do? Well, that brings us to our last section, beyond perfect control. So what's the big takeaway here? I think it's this. We have to change our entire goal. If trying to build a perfect, unbreakable cage for AI is a logical myth, then our whole strategy has to shift from prevention to adaptation. We have to learn to manage a world we can't perfectly control. Now, this doesn't mean we just give up and hope for the best. Not at all. It means we have to be smarter. The real focus in AI safety now is on practical risk management. Things like constantly monitoring what the AI is doing in real time, always having a human in the loop for the big decisions, and building safety rules that can actually learn and adapt. We're not shooting for perfection anymore. We're aiming for really, really good approximations of safety. Which leads us to this final, massive question that we have to sit with. If we accept that we can't ever have complete, perfect, logical control over our most powerful creations, then how do we learn to live with them? What does that future of coexistence actually look like?